Okay, sorry about that. My camera, I was using my camera over the weekend and I didn't realize how low on battery it had gotten. But, so I think the point we were leaving off was I just drew in the moment diagram arrows. So once you have these, you're going to calculate MBC, MCB, you're going to calculate MBA, MAB, MCD, MDC. You're going to calculate your moments for every segment, right? So that you should end up with two equations per segment. MAB, MBA, etc. Right, so this is for any problem you do, regardless of what it looks like. Once you have those two equations, you're going to use your joints to solve for your actual solve for your rotations. You're going to use your joints to solve for the moments at these points, right? You have MBC and MCB are both unknowns, and M and F and and theta N and theta F are both unknowns. So what we're going to do here is you're going to look at, for example, point B. And point B, so I have MBC here. This arrow is also equal to MBC, and these two are equal and opposite. I'm going to use sum of moments about B in this particular case. So if I do sum of moments about B, and we'll do it this way, positive, I'm going to have that MBC plus MBA is equal to 0. I have an equation for MBC. I have an equation for MBA. I'm going to add those two together, and then I will have a new equation in terms of theta N and theta F. Right. Sorry, in terms of theta A, theta B, and theta C. Right. I'm going to do this for every joint. That'll give me a system of equations. I can solve that system of equations usually you solve them for these rotations first, and then you plug your rotations into your moments, and you can get your moments from there. Now, normally we have these conditions, right, theta N, theta F, but in some cases, based on the problem, we'll know what the rotation is at a specific point. So for example, theta A is going to be 0 because we have a cantilever here. Theta D will also be 0. So when you're once you've written out all your equations, you can go back and you can look at your systems and say, well, I know, for example, that theta A, let's say, for example, my MAB equation, theta A would appear in MAB, but theta A would be 0 because it's a cantilever at that point, so I would ignore it. I would actually only have one unknown at that point. I would only have, in that equation, sorry, I would only have my theta B unknown. And yeah, with that, like I know that I have a feeling that this is very different than pretty much anything we've done this entire semester. And I'm just thinking back on it's been about 20 minutes or so since I recorded the first half of this video, so I'm trying to think back of what we covered or what I covered. But once you go through a couple of examples, I think Professor Letchford went through a couple of examples in great detail on how to do this. Once you go through a couple of examples, it becomes much more apparent, I think. The tricky part here, so like in virtual work, the tricky part was just setting up your problem. The tricky part here is also just setting up your problem, right? You need to make sure that you make the cuts, use the right FEM equations, and make sure that you have a solid grasp in your notation. And then once you do that, everything else is pretty much just algebra for this problem. You're going to have a system of equations. You're going to have a set of unknowns, and then you're just going to rearrange those equations and plug things into one another. So for example, you'll have like equations 1, 2, and 3. You'll plug in equation 1 into equation 2. and you'll use that to solve equation 3, for example. And from there, you'll be able to get your moments. You'll get from that work, once you have MBC, MCB, MA, MD, you are not quite done yet. You still need to draw your actual diagram. So this is all covering the moments, right? Everything we did here was covering the moments. If we want to cover the reactions, we need to look at, or the forces rather, we need to look at something just a little bit different. I'm going to look at, let's just choose one segment at random. Let's choose segment AB here, for example. In segment AB, we can say that I have, I'm going to have shear, right? I'm going to have shear, and let's say that I have something like this, right? So this would be VB, and this would be VA. I'm going to pull this down, so I'll draw that here. So here I had VB, here I had VA. Do you agree here that VA would be my horizontal reaction at A? All right. So then in this case, and here I took this and I rotated it this way so that I end up with a problem like this. You could also pretend that you're rotating it the other way. You get the same thing. I'm also going to have my MAB, and I'll have my MBA. And let's say that I'll just look at problem. We'll use the notations that we have here, right, where we have this force here. I'll have some distributed load here. If I want to solve for VA, I just take the moment about B. Or sorry, I just take the moment about A. That's right, this would be AB, this should be BA. I take the moment about A. In this case, I would have VA times L plus WL times L on 2 minus MAB minus MBA equals 0. And I would just solve for VA. And that's how it would get my, sorry, I'm rushing here because I see my battery's running low again. That's how I would get my MA. So I know this is very, very rushed. I'm sorry that this is being uploaded so late, but I will have office hours on Monday from 2 to 4 p.m. And again, if you have any questions, feel free to either stop by or send us an email, and we'll try to get back to you as soon as possible.